Hello, ladies and gentlemen. This is Dr. Robinson again, and we are continuing our studies, and this time we're talking about the Triangle Inequality Theorem. First, we need to know a protractor is a tool used for measuring the size of an angle. Here's a picture of a protractor. The angle measures in a triangle sum to 180 degrees. So that's important to know. All the angles add up to 180 degrees. The angle measures in a quadrilateral. Quadrilateral is a four-sided figure, sum to 360 degrees. So all four angles in a quadrilateral add up to 360. All measures in a triangle, all three angles add up to 180. So, is it possible to draw a triangle with sides 3 centimeters, 4 centimeters, and 5 centimeters? Yes or no? So let's see. So I got my sticks here, and I'm going to first move around and try to make, let's see, I'll make a obtuse angle. Obtuse angle, obtuse triangle. So let's put the small side there, and let's grab the big line, and let's see, put it on the end, and it doesn't reach over, so I'd have to tilt the stick a little bit more. Let's see. I know. I think I'll try to put the stick on the other end and see if it doesn't reach over far enough. So it's a little short. So it doesn't look like I can make an obtuse triangle out of it. Let's see if I put it on the end again. No. Alright, well, let's try it this way. Let's put the end, the two longest parts together. So the 5 centimeter. And let's put that at the end. And let's see, we'll try to make a different type of triangle, regular acute triangle. So we put that at the end. Now let's get the shortest part, drag that over, put it at the end. Hey, that doesn't reach to the top. So I'm a little short again. So I cannot make an acute triangle out of this either. Well, let's see, what can I do? Alright, let's try to make a right triangle. So let's put this at the end here, on top of that one. Now let's take this side and put it on top, and we have a right triangle. So we can make a right triangle out of sides 3 centimeters, 4 centimeters, and 5 centimeters. So yes, it is possible to draw a triangle, and it would be a right triangle. So our answer would be yes. So let's move on. When trying to construct a triangle with given lengths or angle measures, there are several possibilities that you should keep in mind. 1. The triangle may be uniquely defined. You may only be able to draw one triangle. So that's why it's uniquely. 2. The triangle may be ambiguously defined. You may be able to draw more than one triangle. So it's ambiguous. So you got a lot of triangles that you can make. So more than one. Third possibility, the triangle may be non-existent. So it may not be possible to draw a triangle with those measures. So it's possible not to be able to draw a triangle. Here's some more vocabulary. Triangle angle sum theorem. This theorem states that the sum of the angles are 180. So we mentioned that a little earlier. And here is something new I want to talk about, the Triangle Inequality Theorem. The sum of the lengths of any two sides is greater than the length of the third side. So we're going to talk about that a little bit. So, is it possible to construct a triangle with angles measuring 61, 33, and 86? Well, we just learned a second ago that that if all the angles in a triangle have to add up to 180, let's add it up. 33 and 86. That's 9, 10, carry the 1. That's 6, 9, 10, 18. So that adds up to 180 degrees. So it adds up to 180 degrees. So my answer would be yes, it is possible. I'd be able to make a few of them because there are no lengths given. They're just angles given. So as long as I have 180 degrees in my triangle, I will be able to make different triangles. So let's erase this. So let's erase this. Alright. So yes, a triangle measuring 61, 33, and 86 is ambiguously defined because no side lengths are mentioned. So they didn't mention the length of the side, so we don't know how big it is. So the angle could be a large angle for the two lines together, or it could be short as long as the angle measure is the angle measure. So the side length could be indeterminate. So as long as the angle measure is what is preserved. So it is possible to draw many similar triangles with those measurements, though. So let's move on. So check your understanding so far. See if you understood what we did. If you don't, just write down your questions and we'll be glad to go over it. If you're still uncertain, rewatch the video as well. So let's talk about the Triangle Inequality Theorem. Basically, it just states you have a triangle with three sides. I'll call them X, Y, and Z. If you take two of the sides, if you add them up, they have to be greater than the third side. So X plus Y has to be greater than Z. Or X plus Z has to be greater than Y. Or X plus Z is greater than X. Y plus Z is greater than X, sorry. So just remember, just take two of the sides, any two sides, add them up, and they have to be greater than the third side. That's what the Triangle Inequality Theorem states. So, which best describes a triangle with angles measuring 60, 40, and 100? Ambiguously defined, that means we can make many triangles out of this. Non-existent, that means we cannot make a triangle. Or unique, we can make one triangle. Well, let's see. I remember the angles in a triangle have to add up to 180. So I got 100, I got 40, and I got 60. That adds up to 200. Well, I cannot have more than 180 degrees in a triangle, so I'm going to say my answer is B, non-existent. It doesn't exist because I cannot make a triangle with more than 180 degrees. It wouldn't be a triangle. So B would be non-existent. Here's one for you to try. Which best describes a triangle with angles measuring 80, 90, and 100? A, B, or C? So give it a shot. Check your understanding so far. See if you understand it. If you don't, rewatch the video and write down your questions. Bring them in tomorrow. I'll be glad to answer them. Here we have Mary Kate constructs a triangle with one side 7 centimeters long, another side 10 centimeters long, which is not a possible length for her third side. All right, Mary Kate, I remember the rule is I have my triangle, and not a good looking triangle. I have my two sides, so this could be 10, this could be 7, and this could be the third side. Now, I remember I could add up two sides, and they have to be greater than the third side. So if I add up two sides, 10 plus 7, it's got to be greater than the third side. So 10 plus 7 is 17, and that has to be greater than 2. Now, let me put 2 over here. Instead of 10, 2 plus 7, see if that's greater than 10. 2 plus 7 is 9. 9 is not greater than 10. So that's going to be a problem if I use the 2. So I'm going to take a look at my two smallest sides. So my two smallest sides would be the 7 and the 2. So 7 and 2 has got to be greater than the longest side. So that's going to give me a problem. It's not greater than 10. 9 is not greater than 10. So A is going to give me a problem. So this one I'm going to believe is my answer. So that cannot be the third side. If I take 7 plus 7, that'll give me 14. And that's greater than the 10. If I took 4 plus 7, that's going to be 11, and that's greater than the longest side, 10. And if I definitely put 16, well, 16 will be the longest side. So if I took 7 plus 10, that would be greater than the longest side, 16. And that's 17, that's greater than that. So the only one that would give me a problem would be choice A. So I'm going to say, Mary Kate, the answer is choice A. So 2 plus 7 is supposed to be greater than 10. The smallest two sides must be greater than the third side. So the choice A would be our problem. So the third side, which would not be possible, would be side 2 centimeters. So check your understanding, see if you understand it so far, and write down your questions, and we'll answer them in the morning. So remember, the sum of any two sides of the length must be greater than the third side. So I just say add the two smallest sides, and if it's more than, it's got to be more than the largest side. So here's one for you. Tejan constructs a triangle with one side 5 inches long and another side 7 inches long, which is not a possible length for the third side. So remember, take the two smallest sides and add them together. So like 3 plus 5, add that together, see if that's longer than 7. 3 plus 5 is 8. Let's get a pen. 3 plus 5, see if that's greater than 7. 3 plus 5 is greater than 7 because that's 8. And 8's greater than 7, so that's not it. And let's try 11. 5 plus 7. Those are my two smallest sides. See if that's greater than 11. That's 12. So that's not it. Try this one, 6. 5 plus 6, because 6 is my smallest side. And 7. 5 plus 6 to see if that's greater than 7. And that's 11. That's greater than 7. So that's not it. So it's got to be this one. 5 plus 7, those are my two smallest sides. Let's see if that's greater than 12. 5 plus 7 is 12. Wait a minute, 12 is not greater than 12. So my choice answer is going to be D. Because that's the only choice where it didn't work out. The two smaller sides were not greater than the larger side. So Dejan, I'm going to pick choice D, and there it is. D is correct. 5 plus 7 is supposed to be greater than 12, but 12 is not greater than 12, so D is the correct response. So here's a question for you. Which set of lengths cannot be used to make a triangle? So give it a shot. I hope you got something out of this lesson. So bring in your questions tomorrow, and I'll be glad to answer them. So this is Dr. Robinson signing off. See you tomorrow. Bye-bye.